Subscript?
Is what a subscript?
In one of those boxes.
I don't know which one you're talking about.
S x bar 1?
Yeah.
No, that is the standard deviation of the first mean minus the second mean.
Okay.
So these are all on the same level of subscript, but there are subs.
Yeah.
Yeah.
That's fine.
Okay, so this is a nice flowchart. So here's the starting spot for two-sample hypothesis testing for means. Are both population standard deviations known? Okay, so then you go this way with yes. Are both populations normal, or are the sample sizes both Thursday? That's a Z Thursday. At least 30, that's the Z-test, and this is 8.1. This is what we've already done. But if you don't know the population standard deviation, so over here is a Z-test. If you don't know the population standard deviation, then we're going to do t-tests. So this one is all t-tests. Today what we're learning is all about t-tests. We're basically doing the bottom half of this flowchart. We're going to do both at the same time. So if the answer is no, that both populations are normal, or that the population standard deviations aren't known, if they're not normal or both the sample sizes are at least 30, then you cannot do this. So this is like a no-go type scenario. If you hit this, then you just can't do it at all, and you say impossible. If the population is normal or both samples are at least 30, then the question is, are the population variances equal, which means basically, do they vary equally? And it'll say that in the problem. Sometimes they call this pooled, whether something is pooled or not pooled. It is when the variances are equal. So if the answer is yes, we called this, this is the pooled option. We're talking about that today. And if the answer is no, it is still a t-test. This is a t-test. And if the answer is no, it's still a t-test. This is not pooled. I have no idea why it's called pooled or not. It really doesn't matter. The only thing that matters about that is that there's in your calculator, when you do it, the test in your calculator, it says pooled or not pooled instead of variances equal or not equal. All right. Now, this is super gross, all of this stuff. Let me try to explain this to you. So this is the top part of the formula you're going to use. Do you remember this from before, that x bar 1 minus x bar 2 minus mu 1 minus mu 2? Do you remember that this stuff was always 0 up here? It's still 0, okay? And on the bottom is another formula. So the formula could be this one, or it could be that one, plus this, which is horrible. So if the variances are equal, which is basically the worst option to happen with formulas, so we're going to write out the whole formula together. In fact, I'm going to need more space. All right, here's the formula. If it is pooled on top of this, so it's t equals, and on top of the thing, it is x bar 1 minus x bar 2 minus mu 1 minus mu 2, which is 0, so I'm just going to leave it out. Okay, so then it would be, on the bottom are two separate giant square roots. And one is going to be n sub 1 minus 1 s squared 1 plus n sub 2 minus 1 times s squared 2 over n sub 1 plus n sub 2 minus 2. And that's multiplied by 1 over n sub 1 plus 1 over n sub 2. Okay, so that's the formula, which is a regular old nightmare. for a pooled data test, which means variances are equal. If it is not pooled, the formula is a little easier, but still not great. On top is still your x bar 1 minus x bar 2. And for that, it would be, oh, and we should write this in this box. The degree of freedom is equal to n sub 1 plus n sub 2 minus 2. And over here, this one's a little easier. The bottom is simply s squared 1 over n1 plus s squared 2 over n2. Now, hopefully you don't have any problem. Oh, and the degree of freedom is whichever one's smaller. It's either n sub 1 minus 1 or n sub 2 minus 1. The formulas that we did before, I always think it's funny when my, especially AP Stats kids are like, is x minus mu over sigma going to be on the formula sheet? And I'm like, well, yes, but I hope you remember that one. This will be. This will be on the formula sheet. Of course, the problem is putting it together and figuring out exactly what they want. When will this be a problem?
Every time.
No? Okay, maybe for Tegan, who thinks that things are going to be the worst case scenario possible.
Is it a written one explaining what it means?
Explain it, yeah, not a written one.
The
No. The multiple choice, because that's the one where they might have like A is option A, might have a formula like this, B might have a formula like that. You got to select which one's right. But when it comes to you doing free response, you can just always do it on your calculator, and all this math is done for you, and you don't even have to figure out what formula to use. Do you understand?
Will they know that you know what you're talking about if you use the calculator?
Yeah, well, yes, because you're getting the right answer, but you would also write down in your free response, on my calculator, I selected 2-sample t-test pooled. And that way they know, okay, they're doing the right thing. So we're going to do this. We're going to do them by hand, and we're going to do them by calculator, and we're going to do them together. So on the next page is the whole test. We don't really need to go over the T-chart of explanation because it's the same thing as usual. You know, write a null and alternative, all that stuff. We're just going to do the